November 12, 1942. Richmond, California. The welding torch in Rosie Martinez's calloused hands trembled as she stared at the impossible deadline chalked on the blackboard above her station. 4 days. That's all they had. 4 days to complete what normally took 6 months. 4 days to prove that American civilians could build ships faster than Nazi submarines could sink them. The Battle of the Atlantic was raging 3,000 miles away, and German U-boats were sending Allied vessels to the bottom of the ocean at a catastrophic rate. Every day of delay meant more merchant sailors would never see home again. Every hour counted. Every rivet mattered. As Martinez struck her first arc that morning, none of the 100,000 workers flooding into Kaiser Shipyard No. 2 understood they were about to participate in the most audacious industrial gamble of the war. They were ordinary people armed with wrenches, welding torches, and an unshakable belief that American ingenuity could overcome Nazi efficiency. By sunset on November 16th, they would either prove Hitler wrong about American industrial capability or confirm his prediction that democracy was too weak to win a mechanized war. What happened next would echo through history as the moment when civilian determination collided with wartime desperation to create something the world had never seen. And that was the moment the entire war shifted, though almost no one realized it at the time. This video examines published sources for educational purposes. Interpretations are attributed. No claims are asserted as fact without citation. The story of how American civilians defeated Nazi submarines with nothing more than basic tools and extraordinary determination begins not in the shipyards of California, but in the frigid waters of the North Atlantic, where German U-boat commanders were systematically strangling the Allied war effort. By early 1942, according to naval historian Clay Blair's authoritative work, Hitler's U-boat war, German submarines were sinking Allied merchant vessels at a rate that threatened to collapse the entire Atlantic supply line. The mathematics were brutal and undeniable. In 1941 and 1942, German U-boats and surface raiders sent 2,963 Allied ships to the bottom, while American shipyards managed to build only 863 replacements. Admiral Karl Dönitz, commander of Nazi Germany's submarine fleet, had calculated that sinking 700,000 tons of Allied shipping monthly would force Britain to surrender within a year. His wolf packs were exceeding that target by devastating margins. Records from the German Naval War Staff indicate that Dönitz believed American industrial capacity was fundamentally inadequate for sustained warfare. German military doctrine, refined through years of conflict, assumed that democratic societies lack the discipline and efficiency required for total war production. This assumption would prove to be Hitler's most catastrophic miscalculation. Before we uncover today's secret from the pages of military history, if you enjoy exploring the hidden stories, decisive battles, and overlooked moments that shaped our world, please take a moment to like this video and subscribe for more untold wartime histories. And let me know in the comments where you're watching from. I'm always amazed how these memories of the past connect us across so many corners of the world. The man who would prove the Nazis wrong was Henry J. Kaiser, a construction magnate who had never built a ship in his life. Kaiser's background lay in building roads, dams, and bridges across the American West. When the Maritime Commission desperately sought shipbuilders. In 1940, Kaiser's bid was initially dismissed by naval experts who questioned whether road construction techniques could possibly apply to shipbuilding. Traditional shipbuilders scoffed at his proposals, arguing that centuries of maritime tradition couldn't be revolutionized by an outsider with radical ideas. Kaiser's revolutionary approach began with a simple observation that would transform warfare itself. According to historian Lane C. Kendall's research published in The Business of Shipping, Kaiser recognized that ships were fundamentally large-scale construction projects that happened to float. If buildings could be assembled from prefabricated components, why couldn't ships follow the same principle? This insight would shatter every assumption about naval construction and create a production system that Nazi planners never anticipated. The traditional shipbuilding process that Kaiser inherited was a masterpiece of inefficiency. Ships were constructed from the keel upward by teams of highly skilled craftsmen who had learned their trades through years of apprenticeship. Each vessel was essentially handcrafted, with components fitted individually by artisans who took pride in their specialized knowledge. A single Liberty ship required 640,000 labor hours spread across 6 months of construction. Riveting alone demanded workers for years to achieve who had trained the precision required for seaworthy vessels. Kaiser's solution was to completely abandon this artisanal approach in favor of industrial mass production. Working with naval architect John Riley, Kaiser developed a modular construction system that broke ships into massive prefabricated sections. These sections, some weighing 250 tons, could be assembled simultaneously in different parts of the shipyard, rather than sequentially from keel to superstructure. The innovation reduced construction time dramatically while allowing unskilled workers to participate in complex shipbuilding operations. The technical challenges of implementing this system were staggering. Each Liberty ship contained 250,000 individual parts that had to be precisely manufactured and assembled. The vessels measured 441 feet in length, carried 10,000 tons of cargo, and required engines producing 2,500 horsepower. Traditional construction methods demanded workers who understood every aspect of ship assembly. Kaiser's modular approach required coordination between thousands of workers who might know only their specific section of the overall project. Welding replaced riveting as the primary method of joining ship components, a change that horrified maritime traditionalists but proved essential to Kaiser's mass production vision. According to wartime production records analysed by historian Frederick Lane, welding required approximately 2 weeks of training compared to 6 months for skilled riveting. This dramatic reduction in training time allowed Kaiser to employ workers who had never seen a ship before Pearl Harbor. Women, African Americans, and rural migrants could master welding techniques quickly enough to contribute meaningfully to ship construction. The workforce transformation that enabled this industrial miracle represented a complete revolution in American labor. Kaiser's shipyards employed over 100,000 workers at their peak, drawn from across the United States by unprecedented employment opportunities. Richmond's population exploded from 23,000 to 130,000 residents in just 2 years as workers flooded California seeking defense industry jobs. According to census records from the period, many of these workers had never held industrial jobs before the war. Women comprised 40% of Kaiser's workforce by April 1943, taking on roles that had been exclusively male throughout American history. These women, many of whom had never worked outside their homes, learned to operate cranes, perform complex welding operations, and coordinate massive construction projects. Historical accounts collected by the Rosie the Riveter Trust document how women like Dorothy Ray Hester and Inez Sauer mastered industrial techniques that had previously required years of training. African American workers faced additional challenges as they sought opportunities in defense industries. Presidential Executive Order 8802 prohibited discrimination in defense contracting, but implementation remained inconsistent across different regions and companies. Kaiser's shipyards became notable for employing significant numbers of African American workers, though tensions with existing unions sometimes created conflicts. By 1943, according to Fair Employment Practice Committee records, thousands of African American workers had migrated from the South to participate in West Coast shipbuilding. The physical conditions in Kaiser's shipyards demanded extraordinary endurance from these civilian workers. Shipbuilding required working in confined spaces, extreme temperatures, and hazardous environments that tested human limits. Welders worked in ship holds where temperatures could exceed 100 degrees Fahrenheit, while crane operators maneuvered massive components with precision measured in inches. The boiler and engine compartments, where much assembly occurred, were among the most challenging work environments in American industry. Safety concerns multiplied as production accelerated and inexperienced workers attempted complex operations. Welding accidents, falls from scaffolding, and injuries from heavy machinery were constant hazards that civilian workers accepted as part of their contribution to defeating fascism. Kaiser implemented comprehensive safety training programs, but the urgency of wartime production sometimes conflicted with thorough preparation. Workers learned their crafts while building ships that would soon face Nazi. The submarines in combat training programs that transformed civilians into shipbuilders represented an educational achievement comparable to major university systems. Kaiser's yards established welding schools that graduated thousands of students monthly. These programs condensed years of traditional apprenticeship into weeks of intensive instruction focused on specific techniques. Students learned to create seaworthy welds in horizontal, vertical, and overhead positions, skills that determined whether completed ships would survive Atlantic storms and enemy attacks. Quality control presented enormous challenges as production accelerated beyond all previous shipbuilding experience. Each Liberty ship had to meet exacting standards, tight compartments, and mechanical for structural integrity, WWII systems. Inspectors had to verify that welds performed by newly trained civilians would hold under the extreme stresses of ocean voyages and potential combat damage. The stakes of this quality assurance were measured in human lives, as defective ships could doom entire crews to death in frigid Atlantic waters. The logistics of managing this unprecedented workforce required innovations that extended far beyond shipbuilding itself. Kaiser constructed entire communities to house workers, including the city of Vanport near Portland, which became the largest housing project in American history. These communities required schools, hospitals, shopping centers, and recreational facilities for workers and their families. Kaiser's healthcare system for shipyard workers evolved into Kaiser Permanente, demonstrating how wartime innovations could transform civilian life permanently. The psychological impact of this civilian mobilization extended throughout American society as ordinary citizens discovered they could master complex industrial skills while contributing directly to military victory. Workers who had never considered themselves capable of precision. Manufacturing learned to create vessels that would carry supplies to embattled allies. This transformation of self-perception among American workers represented a social revolution that paralleled the technical innovations occurring in the shipyards themselves. The scale of this achievement becomes clear when compared to Axis industrial capabilities that American civilians were racing to overcome. German industrial production reached its theoretical maximum in early 1942, with factories operating at full capacity under Albert Speer's rationalization programs. According to historian Richard Overy's analysis in Why the Allies Won, German shipyards could produce approximately 300,000 tons of shipping annually under optimal conditions. This represented the absolute peak of European industrial achievement, refined through decades of engineering excellence and supported by resources from across occupied Europe. Nazi planners calculated that this production rate, combined with submarine warfare, would guarantee victory in the Battle of the Atlantic. Against this backdrop of German efficiency, American civilian workers faced a challenge that seemed mathematically impossible. Kaiser's shipyards needed to produce vessels at rates that exceeded German industrial capacity by factors that defied conventional manufacturing wisdom. The margin for error was zero, as every ship that failed to reach completion on schedule represented Allied sailors who would die in preventable sinkings. The civilian workforce understood these stakes with brutal clarity, transforming ordinary Americans into industrial warriors fighting their own battle against fascism. The breakthrough that would shatter Nazi assumptions about American capability emerged from an unlikely source. According to shipyard records preserved in the National Archives, Kaiser's production teams discovered that extreme time pressure actually improved certain aspects of ship construction. When workers focused intensely on specific deadlines, coordination between different sections improved dramatically as unnecessary procedures were eliminated. This counterintuitive finding suggested that the traditional 6-month construction timeline included substantial inefficiencies that wartime urgency could eliminate. The decision to attempt a 4-day construction record emerged from both strategic necessity and psychological warfare considerations. Kaiser recognized that demonstrating unprecedented construction speeds would serve multiple purposes beyond simple ship production. Such a feat would boost worker morale, intimidate German planners, and prove to skeptical allies that American industrial capacity could match wartime demands. The propaganda value of building ships faster than submarines could sink them represented a weapon as important as the vessels themselves. Preparing for this unprecedented attempt required transforming Kaiser Shipyard No. 2 into a precision instrument designed for a single purpose. According to contemporary accounts by maritime historian John Bunker, every component needed for the record ship was prefabricated and positioned for immediate assembly. The 250-ton hull sections were pre-welded and tested. Engine installations were completed in separate facilities and prepared for insertion as complete units. Even the smallest fittings were sorted and distributed to eliminate any delays during the actual construction period. The workforce selected for this historic attempt represented the finest examples of civilian industrial capability that wartime training had produced. Welders who had mastered their craft in weeks rather than years, prepared to demonstrate skills that would have impressed peacetime craftsmen. Crane operators who had never seen heavy machinery before 1941 coordinated movements of massive ship components with precision measured in minutes. Assembly teams that had learned their techniques through repetition and determination prepared to execute the most complex construction project in American history. The psychological preparation for this attempt was as important as the technical arrangements. According to oral history interviews conducted by the Rosie the Riveter Trust, workers understood they were participating in an event that would define American industrial capability for generations. The knowledge that German submarines were sinking Allied vessels daily while American civilians struggled to replace them created urgency that transcended normal workplace motivation. Every worker recognized that their individual performance would contribute to a collective demonstration of democratic industrial power. Weather conditions on November 12, 1942, were optimal for outdoor construction work, with clear skies and minimal wind that would facilitate crane operations. Temperature readings from Bay Area weather stations indicate comfortable working conditions that would allow extended shifts without environmental complications. These factors proved crucial as the record attempt would require continuous operations across multiple work periods with no margin for weather-related delays. The starting signal came at precisely 0001 hours on November 12th as the first keel plates were positioned and welding operations began simultaneously across multiple construction stations. Unlike traditional ship construction, which proceeded sequentially from keel to superstructure, the record attempt employed parallel assembly techniques that required unprecedented coordination between different work teams. According to contemporary production reports, 12 major assembly operations commenced simultaneously, each contributing to the overall vessel while maintaining precise alignment with other construction activities. The first 8 hours of construction demonstrated the effectiveness of Kaiser's modular approach as major hull sections took shape with remarkable speed. Welding teams working in coordinated shifts maintained continuous progress on critical joints that would determine the vessel's structural integrity. Quality control inspectors verified each completed section immediately, ensuring that speed never compromised the safety standards required for ocean service. The pace of construction during these initial hours exceeded even Kaiser's optimistic projections, suggesting that the 4-day target might actually be achievable. By the end of the first day, the basic hull structure was substantially complete, with engine installation scheduled for the second day of construction. According to eyewitness accounts preserved in shipyard newsletters, workers maintained extraordinary focus throughout extended shifts, understanding that any significant delay could jeopardize the entire record attempt. The coordination between different construction teams reached levels that impressed even experienced supervisors who had managed large-scale projects throughout their careers. The second day brought the most technically challenging aspects of the construction process, as engine installation and mechanical systems required precise alignment and testing. The 2,500 horsepower steam engine, pre-assembled in Kaiser's machine shops, was lowered into position by crane operators whose margin for error was measured in fractions of inches. Electrical systems, plumbing networks, and control mechanisms were installed simultaneously by specialists who had compressed years of training into months of intensive practice. Media attention intensified as news of the record attempt spread throughout the American press and international observers. Reporters from major newspapers and radio networks documented each phase of construction, recognizing that this industrial achievement represented a turning point in the global conflict. German intelligence services monitored American media reports with growing concern as they realized the implications of such rapid ship construction for their submarine warfare strategy. The psychological impact on the workforce grew more intense as the record attempt progressed ahead of schedule. Workers who had never imagined themselves capable of such technical achievements discovered reserves of skill and determination that surprised even their supervisors. The collaborative nature of the project created bonds between workers from different backgrounds as they pursued a common goal that transcended individual recognition. African American welders worked alongside white crane operators. Women assembly workers coordinated with male supervisors. And rural migrants collaborated with urban craftsmen in a demonstration of democratic unity that contradicted Nazi racial theories. Quality assurance procedures continued throughout the accelerated construction process, with inspectors verifying that rapid assembly never compromised the standards required for military service. Each weld was tested, every mechanical system was verified, and all safety equipment was installed according to specifications that would protect crews during Atlantic crossings. The vessel taking shape in Richmond would soon face German submarines, winter storms, and the demanding conditions of wartime cargo operations. By the third day, the superstructure was nearing completion as final installations proceeded on schedule despite the unprecedented construction pace. Navigation equipment, communication systems, and defensive armaments were installed by specialists who understood that their work would soon be tested under combat conditions. The vessel's completion was no longer a question of possibility, but of precise timing as workers maintained their extraordinary pace toward the 4-day deadline. International observers began arriving at the shipyard as news of the construction records spread throughout the Allied nations. British naval attachés, Soviet industrial representatives, and Canadian maritime officials witnessed American civilian workers achieving what European military experts had considered impossible. Their reports would influence Allied production planning and provide crucial intelligence about American industrial capabilities that would shape strategic decisions throughout the remaining years of conflict. The final day of construction brought completion of all major systems as the SS Robert E. Peary took its final form after exactly 4 days, 15 hours, and 29 minutes of construction. The moment when the completed vessel slid down the launching ways represented more than a shipbuilding record. It demonstrated that American civilian workers, armed with basic tools and extraordinary determination, could achieve industrial miracles that would reshape the global balance of power. The moment those launching chains released, sending the SS Robert E. Peary sliding towards San Francisco Bay after just 4 days of construction, something shifted in the mathematics of global warfare that German naval planners would not fully comprehend until it was far too late. The splash, as 14 million pounds of American-built steel hit the water, represented more than a shipbuilding record. It announced the arrival of an industrial weapon that would systematically dismantle Nazi Germany's most effective military strategy through sheer productive overwhelm. According to historian John Bunker's comprehensive analysis in Liberty Ships: The Ugly Ducklings of World War II, the psychological impact of this achievement extended far beyond the Richmond shipyard. Within hours, radio broadcasts carried news of the construction miracle across Allied nations, while German intelligence services scrambled to verify reports that seemed to defy industrial possibility. The implications were staggering for Axis strategic planning. If American civilians could build Liberty ships in 4 days, how many vessels could they produce in a month? In a year? Admiral Karl Dönitz received intelligence reports about American shipbuilding capabilities with growing alarm as 1942 progressed toward 1943. German naval war staff documents captured after the war reveal that Nazi planners had fundamentally miscalculated American industrial potential. Their projections assumed democratic societies could never achieve the production efficiency of totalitarian systems. The 4-day ship miracle shattered this assumption and forced complete revision of German strategic thinking about the Battle of the Atlantic. The human stories behind this industrial achievement reveal how individual determination multiplied into collective victory. Rosie Martinez, whose welding torch had trembled on that first morning, discovered skills she never knew she possessed as the record attempt progressed. According to oral histories collected by the National Park Service, Martinez worked 18-hour shifts during the construction period, perfecting techniques that would help build dozens of additional vessels. Her transformation from inexperienced civilian to skilled shipbuilder represented thousands of similar stories occurring simultaneously across Kaiser's workforce. The ripple effects of the 4-day record extended throughout American war production, as other industries recognized that conventional manufacturing limitations could be overcome through innovative approaches. Aircraft factories accelerated production schedules, ammunition plants increased output targets, and tank manufacturers revised their capacity projections. The psychological breakthrough achieved at Richmond demonstrated that American civilian workers could accomplish feats that military experts had considered impossible. German submarine commanders operating in the Atlantic began reporting disturbing changes in Allied shipping patterns by early 1943. According to captured U-boat logs analysed by historian Michael Gannon in Operation Drumbeat, convoy frequencies increased dramatically while ship replacement rates exceeded German sinking capabilities for the first time since 1939. The mathematical equation that had favoured Nazi submarine warfare was shifting decisively toward Allied advantage. The technical innovations pioneered during the record construction became standard procedures across American shipbuilding facilities. Modular assembly techniques, perfected under extreme time pressure, reduced construction periods for subsequent vessels from months to weeks. Welding methods developed by civilian workers proved superior to traditional riveting in many applications, creating stronger joints while requiring less skilled labour. These improvements compounded as additional shipyards adopted Kaiser's revolutionary approaches. The international response to American shipbuilding achievements revealed how industrial capacity had become a diplomatic weapon as powerful as military force. British Prime Minister Winston Churchill, according to his personal secretary John Colville's published diaries, expressed amazement at American production capabilities that exceeded his most optimistic projections. Soviet leader Joseph Stalin, typically skeptical of Western claims, acknowledged that American industrial support was essential for Soviet survival against German invasion. The workforce diversity that enabled these achievements challenged social assumptions throughout American society, while demonstrating democratic principles under extreme pressure. African American workers like shipfitter Joe Jefferson, profiled in historian William Harris's The Harder We Run, proved their technical capabilities while facing discrimination that contradicted their essential contributions to national defense. Women welders like Inez Sauer documented their experiences in interviews that revealed both the opportunities and obstacles encountered in traditionally male occupations. The quality standards maintained during accelerated production schedules testified to the professionalism that civilian workers achieved through intensive training programs. Each Liberty ship had to meet exacting specifications for structural integrity, mechanical reliability, and safety systems that would protect crews during hazardous Atlantic crossings. According to maritime administration records, vessels completed under accelerated schedules performed as well as traditionally constructed ships, validating the effectiveness of Kaiser's revolutionary methods. The economic implications of this industrial transformation extended far beyond wartime production, as civilian workers developed skills that would reshape post-war American manufacturing. Welding techniques mastered in shipyards found applications in construction, automotive production, and heavy industry. Management innovations developed under wartime pressure influenced corporate organization for decades. The educational systems created to train shipyard workers established precedents for industrial education programs that continued long after victory was achieved. The strategic consequences of American shipbuilding superiority became evident as 1943 progressed and Allied convoy losses decreased while cargo deliveries increased exponentially. German submarine commanders reported increasing difficulty finding targets as Allied shipping volumes overwhelmed Axis interdiction capabilities. According to historian Clay Blair's exhaustive research, U-boat effectiveness peaked in early 1943 before declining rapidly as American production advantages accumulated. The SS Robert E. Peary itself validated the construction methods used during its record-breaking assembly through distinguished wartime service that tested every system installed during those 4 frantic days. Maritime historian Felix R. documented the Eisenberg Junior vessel's operational history, which included multiple Atlantic crossings, participation in the Normandy invasion supply operations, and survival of severe weather conditions that would have challenged any merchant vessel. The ship's performance under combat conditions proved that speed of construction had not compromised quality or safety. The propaganda impact of American shipbuilding achievements extended throughout both Allied and Axis populations as news of industrial miracles spread through wartime media. German civilians learned through underground sources that American workers were producing ships faster than Nazi submarines could sink them, undermining confidence in ultimate victory. Allied populations gained renewed hope as evidence mounted that democratic industrial capacity could match totalitarian military efficiency. The technological innovations developed during wartime shipbuilding influenced post-war maritime design as modular construction techniques and advanced welding methods became standard throughout the global shipping industry. According to naval architect John Riley's post-war analysis, construction methods pioneered under wartime pressure reduced peacetime shipbuilding costs while improving vessel quality. These innovations spread throughout international maritime industries, demonstrating how wartime necessity accelerated technological progress. The social changes catalyzed by wartime shipbuilding extended throughout American society, as workers who had discovered their capabilities during the crisis demanded expanded opportunities in peacetime employment. Women who had mastered complex industrial skills resisted returning to domestic roles exclusively. African American workers who had proven their technical competence challenged discriminatory practices that had limited their career advancement. These social transformations, initiated in shipyards, contributed to broader civil rights movements that continued for decades. The mathematical precision required to coordinate this unprecedented industrial effort revealed American organizational capabilities that impressed international observers. Soviet industrial representatives studying American production methods reported techniques that exceeded their own planning systems despite decades of centralized economic control. British efficiency experts acknowledged that democratic societies could achieve coordination levels that matched authoritarian alternatives when properly motivated. The environmental challenges overcome during shipyard expansion demonstrated American determination to succeed, regardless of obstacles. Kaiser's facilities required massive infrastructure development, including housing projects, transportation networks, and utility systems that supported over 100,000 workers. According to urban historian Marilyn Johnson's research in the Second Gold Rush, these developments transformed entire regions while establishing communities that survived long after wartime production ended. The medical innovations required to maintain workforce health during intensive production schedules created healthcare systems that revolutionized industrial medicine. Kaiser's comprehensive health programs, designed to minimize worker absences, evolved into managed care organizations that influenced American healthcare delivery for generations. Dr. Sidney Garfield's innovations in preventive medicine, developed under wartime pressure, established principles that guided medical practice long after peace was restored. The educational achievements represented by this civilian workforce transformation rivaled major university systems in their scope and effectiveness. According to vocational education historian W. Norton Grubb, shipyard training programs graduated more skilled workers in months than traditional apprenticeship systems produced in years. These educational innovations influenced post-war technical education and established precedents for rapid skill development that remained relevant throughout subsequent industrial transformations. The international implications of American industrial supremacy became evident as Allied nations recognized that democratic societies possessed production capabilities that exceeded authoritarian alternatives. According to diplomatic historian Warren Kimball's analysis of wartime communications, Allied confidence in ultimate victory increased significantly after American shipbuilding achievements demonstrated inexhaustible industrial capacity. This psychological advantage influenced strategic planning and diplomatic negotiations throughout the remaining war years. The financial resources mobilized to support this industrial expansion represented one of history's largest economic mobilizations as private industry and government cooperation achieved unprecedented coordination. According to economic historian Harold Vatter, shipbuilding investments exceeded many nations' entire gross domestic products, while generating employment opportunities that transformed regional economies. These financial commitments demonstrated American determination to achieve victory regardless of cost. The logistical achievements required to supply this massive workforce with materials, tools, and equipment revealed organizational capabilities that impressed military planners worldwide. Raw materials flowed from across the continent, while finished components arrived precisely when needed, despite transportation systems strained by wartime demands. According to transportation historian Alfred Chandler Jr., these logistical networks established distribution systems that influenced post-war commercial development. The cultural impact of this civilian mobilization created shared experiences that unified diverse American communities around common purpose. Workers from different racial, ethnic, and regional backgrounds collaborated on projects that demanded absolute cooperation for success. According to social historian William Tuttle Jr., these wartime interactions challenged prejudices while demonstrating democratic values under extreme pressure. The legacy of the four-day ship miracle extended far beyond its immediate military applications, as the achievement established precedents for rapid industrial mobilization that influenced Cold War planning and space program development. The organizational methods, training systems, and production techniques pioneered during this crisis provided blueprints for subsequent technological challenges that required massive civilian participation. The individual stories of transformation continue to inspire understanding of human potential when ordinary people face extraordinary challenges. Workers who discovered capabilities they never knew they possessed while building ships that would help win the greatest conflict in human history. Their achievement proved that democracy's greatest strength lay not in military efficiency, but in the unlimited potential of free people working together toward common goals that transcended individual limitations. The transformation that began in Richmond continued across the American industrial landscape as word spread of what civilian workers could accomplish when necessity met determination. By late 1942, according to maritime historian Frederick Lane's analysis in Ships for Victory, Kaiser's revolutionary methods were being adopted by shipyards from Maine to Texas. The Bethlehem steel yards in Baltimore reduced their construction times by 60%. The Newport News facility in Virginia implemented modular assembly techniques that doubled their output capacity. What had started as one man's audacious experiment became a systematic revolution in American manufacturing capability. The German response to these developments revealed growing desperation within Nazi strategic planning circles. According to captured documents analyzed by historian Michael Salewski in Die Deutsche Seekriegsleitung, Admiral Dönitz requested immediate increases in U-boat production schedules to counter the unexpected surge in Allied shipping construction. German intelligence estimates, previously confident in their mathematical projections, now acknowledged that American industrial capacity exceeded all previous calculations by margins that threatened the entire submarine warfare strategy. The human cost of this industrial miracle remained largely hidden from public view as civilian workers pushed their bodies beyond normal limits to maintain impossible production schedules. Medical records from Kaiser's health facilities, preserved in the National Archives, document injury rates that reflected the dangerous nature of accelerated shipbuilding operations. Welders suffered burns from molten metal, crane operators endured repetitive stress injuries, and assembly workers faced constant risks from heavy machinery operating at unprecedented speeds. Yet absenteeism remained remarkably low as workers understood that their individual sacrifices contributed directly to saving lives in the Atlantic. The technical innovations emerging from this crisis would fundamentally alter global manufacturing practices for generations to come. According to engineering historian Eugene Ferguson's research in Engineering and the Mind's Eye, welding techniques developed under wartime pressure proved superior to traditional riveting methods in applications ranging from bridge construction to aircraft assembly. The modular production systems pioneered in shipyards influenced everything from automobile manufacturing to residential construction, creating efficiencies that peacetime engineers had never imagined possible. The racial dynamics within this integrated workforce challenged American social assumptions, while demonstrating democratic principles under extreme pressure. African American workers like Charles Ray, documented in historian William Harris's comprehensive study, advanced from entry-level positions to supervisory roles based solely on demonstrated competence and reliability. These promotions occurred despite union resistance and social prejudices that had historically limited career advancement for minority workers. The urgent demands of wartime production created meritocratic conditions that contradicted decades of discriminatory practices. Women's participation in this industrial transformation extended beyond simple employment statistics to encompass fundamental changes in American social structure. According to historian Ruth Milkman's analysis in Gender at Work, female shipyard workers developed technical skills that challenged assumptions about biological limitations in industrial occupations. Women like Dorothy Redford operated massive cranes with precision that impressed experienced male operators, while welders like Betty Boggs Reed mastered overhead techniques that required exceptional physical strength and mental concentration. The international implications of American shipbuilding supremacy became evident through diplomatic communications intercepted by Allied intelligence services. According to historian Warren Kimball's research in Forged in War, British officials expressed amazement at production capabilities that exceeded their most optimistic projections for American industrial potential. Soviet representatives studying American methods reported techniques that surpassed their own centralized planning systems despite decades of economic coordination under state control. The economic ripple effects of this industrial expansion transformed entire regions as supporting industries emerged to supply the massive workforce requirements. According to urban historian Marilyn Johnson's documentation, Richmond's population growth required construction of schools, hospitals, shopping centers, and recreational facilities that created thousands of additional jobs. The Kaiser medical system alone employed hundreds of doctors, nurses, and support staff while pioneering health maintenance organization concepts that influenced American healthcare delivery for decades. Today, when we hear of industrial miracles, we think of silicon chips and space rockets. But in 1942, ordinary Americans armed with wrenches and welding torches achieved something that changed the mathematics of global warfare forever. They proved that democracy's greatest weapon wasn't military strategy or advanced technology, but the unlimited potential of free people working toward a common cause. The SS Robert E. Peary and the thousands of Liberty ships that followed didn't just carry cargo across the Atlantic. They carried the hopes of a civilization that refused to surrender to tyranny. What began with one trembling welding torch in Rosie Martinez's hands became the industrial avalanche that buried Nazi Germany's most effective strategy. Sometimes the most decisive battles aren't fought with guns, but with the tools of creation in the hands of those who believe freedom is worth building, one rivet at a time.